Hello, the aim of this video is to define another form of a complex number, which is called the trigonometric form of a complex numbers. But first, let's look when we do arithmetics on a complex number. Suppose you have a complex number z1 is equal to a plus b iota, and another complex number z2 which is c plus d iota. And suppose you are going to multiply them. You will write a plus b iota times c plus d iota, and then you will multiply this number with this one, and then this number with this one, then this with this one, and this with this one. You have four different products. Okay, and similarly, for example, if you want to divide z1 by z2, if the modulus of z2 is not 0, if you want to divide, then what you have to do, you will write a plus b iota over c plus d iota, and then you will rationalize this thing. In order to rationalize it, you will write its conjugate here. So its conjugate is c minus d iota. C minus d iota. You will multiply and divide by the conjugate of the denominator, and then you will have a lot of calculations. So doing arithmetics on the complex numbers in the Cartesian form, this is the Cartesian form of a complex number. This is also the Cartesian form of the complex number, because it can be written as c comma d in the complex plane, and this can be written as a comma b in the complex plane. So when you write a complex number in the Cartesian form, or a plus b iota, then doing arithmetics is more time consuming. You can see, if I multiply, I have to do a lot of calculations, and even if I divide, I have to do a lot of calculations. In order to simplify these calculations, we will introduce another form of a complex number, which is not the Cartesian form, but it's similar to the Cartesian form. So that form is called the trigonometric form of a complex number. So first we will define the trigonometric form of a complex number, and then once we define it, then doing the arithmetics on the complex number in trigonometric form will be easy to tackle. Okay, so that's why we define the trigonometric form of a complex number. Okay, so first of all, you suppose that you have a complex number z, and it has some position vector that is called OZ. So every complex number has a position vector that is obtained by joining the point z with the origin and drawing a vector. So this is the vector called the position vector. If your z is, for example, here, then you can also draw a position vector. So every point in the complex numbers, so every point in a complex plane has some position vector. For example, if here is a point, we can draw a position vector. Suppose this is the point and you have drawn a position vector which is OZ. But if you write the Cartesian coordinates of z, that are only, the x coordinate is -2 and the y coordinate is +2. So I will write -2, 2, which are the Cartesian coordinates of z. So my aim is to write the trigonometric form or the polar coordinates of this point. So an easy way to do that is to draw this triangle. Okay, so this is a right triangle. If you see, this is the 90-degree angle. So this triangle is a right triangle. So in this triangle, we can find the length, this length, and this length. Okay, so this length is 2, This length is also 2. So these are clear, but this length is what? We don't know. What is the length of this arrow? This, which is the hypotenuse of this triangle. So first of all, we will find its hypotenuse, and then we will use some trigonometric trigonometric ratios on that. So we have a triangle. Maybe I can draw this triangle here in this way. So if this is this is the triangle. Since this distance is 2, this distance is 2, because from here it is 2, and from here this distance is 2, and we have to find this distance. And if we use Pythagoras theorem, that is called, we can easily find this distance. X square is equal to, so according to Pythagoras theorem, this length is the square of this length, which is x, square of this length is equal to 2 square plus 2 square, the square of this length plus square of this length, which is called Pythagoras theorem. This is height, this is base, so height square plus base square is equal to hypotenuse square. Okay, using Pythagoras theorem. So if we find, if we do calculations, this is 4 plus 4, which is 8. Since we have to find x, so x is equal to square root of 8. We are not taking the negative value, we are only taking the positive value of the square root, because this is the length. Okay, so this is just this triangle. I have just rotated it in order to simplify things. Okay, so that means the length of the arrow is square root of 8. So this is square root of 8. Okay, so we have this thing. Now, in order to find the coordinates of this point in polar form, we have to use this triangle. So first of all, let's look. We have two different trigonometric identities, sine theta and cosine theta. Since we need the trigonometric form of a complex number, so in this triangle we will use the trigonometric ratios. We have two trigonometric ratios, sine theta and cosine theta. If I apply sine theta on this triangle, if this is the theta, then I have 2 by x, which is height over hypotenuse. So sine theta is 2 by x. But from here, x is square root of 8. If I simplify square root of 8, it is just 2 times square root of 2. So I will put 2 in place of x, I will write 2 times square root of 2. But this 2 will get cancelled with this one. So I have 1 by square root 2. Okay, so sine theta is equal to 1 by square root 2. So that means this angle theta can be found easily, because if sine theta is 1 by square root 2, then we can find theta by shifting sine to the right hand side. When I shift this sine to the right hand side, it will become sine inverse. So sine inverse of this number 1 by square root 2. So if I use my calculator, it will give me the angle of 45 degrees or pi by 4. Pi by 4 in radian, and in degrees it is 45. Okay. So both are the correct answer. The one is in radian, the other one is in degrees. So my angle is pi by 4 or 45 degrees. Okay, so theta is 45 degrees. But if we look at the picture, in the picture, my theta is from here to here, okay? Since in the picture, the theta is from here to here, so that means I have to add, but I have only counted this theta, so that means I have to add this 90 degree also. Because when I was dealing with this triangle, that means I was only doing this angle. But my total angle is from here to here, so that means I have to add this 90 degree also. So the exact value of theta is this angle plus 90 degrees. Because of the second quadrant, this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. So if my triangle was in the first quadrant, then there is no need to add this 90 degrees. But since it is in the second quadrant and my original angle is 90 degree plus this angle, so that's why I have added 90 degrees in the final answer. Okay, so my angle theta will be 135 degrees. Now I have found my angle theta. Now again apply sine and cosine on the triangle. So here is the triangle. So this angle is 135 degrees. Now if I apply sine of 135 degrees, it is this divided by this, since this value x is equal to 2 times square root 2, which we have already found. So sine of 135 is 2 by 2 square root 2. Okay, just write it as square root 8. No need to write in this way. Similarly, cosine of 135 degrees is equal to this divided by this, which is again 2 by square root 8. Okay, now come back to the point z. Since z was equal to minus 2 comma 2, so this 2 is coming from the height and this 2 is coming from the base. So from here, if I find the value of this height, which is 2, so I have to find this value. So I will take this square root here. It will get multiplied with this one. So square root 8 times sine 135. Similarly from here, if I separate this 2, I will shift this 8 here. I will get 2 is equal to square root 8 times cosine of 135. So I have to write this 2 and this 2 here. So in place of this 2, I will put its value, and in place of this 2, I will put the other value, which is this one. So the first value is square root 8 times cosine of 135 comma square root 8 times sine of 135. Okay, so this is called the trigonometric form of a complex number. So given form of the complex number, so one more thing, once we have done with the angle, once we have found the angle, and then there is no need to write this minus here, because we have covered that thing with the angle. Okay, since this 2 was in the opposite direction, it was not in this direction. If it was in this direction, that my triangle would be in the first quadrant. Since I have not written minus 2, I have written plus 2 here, and I have considered and I have added this 90 degree when I found the angle here. So that means there is no need to care about this negative, okay, because my angle will tell me this 2 will be negative. Okay, this angle is in the second quadrant, so no need to write this minus. So this is called the trigonometric form of a complex number, and this is the Cartesian form, and this is the trigonometric form. Why it is trigonometric? Because it involves trigonometric ratios, cosine and sine. So given any complex number, we can find its angle theta, and we can convert its Cartesian coordinates into polar coordinates.